Again, we have x squared minus 4x minus 12. This factors into an x plus something and an x minus something. You know it's x both places because you get an x squared. And an x here and an x here is going to give you the x squared. It's going to be plus and minus, and these numbers have to multiply out to negative 12. So what are the possibilities? Well, it could be x plus 12 times x minus 1. It could be x plus 1 times x minus 12. It could be x plus 2 times x minus 6, or x plus 6 times x minus 2, or x plus 3 times x minus 4, or x plus 4 times x minus 3. Because, of course, 12 can be written as 12 times 1, 6 times 2, or 4 times 3. Since we have a plus and a minus involved, we have two possibilities for the 12 and the 1. Could be this way with the 12 added, or this way with the 1 added, and then the other one subtracted. Similarly on these. Now, we know you do the distributive law on this, or shortcut it. Excuse me. You're going to have a 12x here and a minus x here. It's going to give you like an 11x, right? No, it's nowhere near 11. Okay? So we can cross out this possibility without actually multiplying it. We should get where we can multiply these things are. Okay? And that thing I mumbled was pretty easily. Okay. Similarly here, you know, we get a negative 12x here and an x here. That's not going to give us negative 4x. Okay, now here we have a possibility. This is going to give us, let's see, we're going to get x squared plus 2x minus 6x minus 12. Well, that equals x squared minus 4x minus 12, doesn't it? So now we've got two factors that multiply out to this, and that's what we're after. The rest of these factors can't work. There's only one way factor. So we can cross out the rest of the possibilities since we found this one. So we can say that x squared minus 4x minus 12 equals x plus 2 times x minus 6. Is that clear? Now, you don't always have to do this. There are all kinds of tricks you can use since it's a monic polynomial with a 1 in front of your x squared. We're going to look in a little while at polynomials that have a number besides 1 in front of x squared. And again, we want to be able to write out all the possibilities. Now, sometimes you'll just see it, especially if you've done a lot of them. But sometimes it's pretty mysterious, and you're going to have to play around with multiple possibilities, which is why I'm writing them out this way. Okay, this one. If this factors, it's going to be as x plus something times x plus something. And both of these are plus. They have to have the same sign. The number here has to have the same sign as it does here in order to get a plus 12. And then since you got a plus 8x, well, then they both got to be positive. If they're both negative, you get a negative here. If you work in these problems, you understand how that works. Okay, so again, you get x plus 12 times x plus 1. But we don't have to do x plus 1 times x plus 12 like we did over here when we had a plus and a minus. Okay. If you've got a negative here, then you're going to have to do the plus and minus on every possible factoring of 12, every possible breakdown of 12 into 2 factors. Okay? So here it's actually a little simpler. it could be x plus 6 times x plus 2, or x plus 4 times x plus 3. Well, you multiply this one out, you're going to get a 12x and an x, which makes 13x, not 8x. So we'll have to multiply this one out. Well, you're going to get a 6x and a 2x. 6x and a 2x going to add up to 8x, so that's it. Then we check to be sure. Okay, that's straightforward. We write out the distributive law and then we distribute once more. Losing track of what I see. These maps have the disadvantage you don't get your peripheral vision as well. And I just couldn't see what I was looking for. Okay? Now I lower my head a little bit and I can see it. So it's kind of a no-brainer. I almost tripped over a fan cord today because I couldn't see it. Okay? Didn't see the floor in front of me. Saw the fan. I knew it was plugged in, so I should have seen it. I didn't. But nobody else had that problem. Worst thing would have happened is I'd unplugged the fan. It wasn't a big deal. Okay, so there we got it, right? Just by using the distributive law, I'm not going to explain every step, because we've done that many, many times. Okay. Now let's look at these two examples. Since I finally found all my errors, I didn't put the cube in. And look, I did it again. Okay? It's because we've been writing out a lot of quadratics, so I just kind of automatically start with an x squared even when I intend an x cubed. My hand writes it, my fingers type it. Just kind of goes in automatic and doesn't pass through my brain, my conscious brain. Okay, so here we have it. So, well, we can do this. This is fairly straightforward. We can do x squared times x plus 3. That factors this. And then we can do 4 times x plus 3. Both ways we get an x plus 3. So these match. Now if these don't match, then it didn't work. There might be another way to factor, okay? So anyhow, we have this. And then by the distributive law, that's just working the distributive law backwards, that's x plus 4 times x plus 3, because, of course, I want to write a square every time I write x. Stop that. Okay, now, this is distributive law backwards. If you apply the distributive law, it's supposed to be a square. Sorry, I take that back. Okay, right? The hand's going to pout for a long time. Okay, x squared plus 4 times x plus 3. And if you, what I was trying to say is, if you then apply the distributive law here, you do get x squared times x plus 3, which is here, and then plus 4 times x plus 3, which you've got here. And if you multiply these out, you get these. You multiply this, you get this. If you multiply this, you get this. See the pattern? Try the same thing here. What we've got here is x squared times x minus 5. And then a little tricky here because of the signs. I can factor a 2 out of this and I'd get negative x plus 5, right? Factor just 2 out of negative 2x plus 10, I get a negative x plus 5. But if I factor out a negative 2, I get my x minus 5. So one way or another, you've got to see that. In any case, this is x squared minus 2 times x minus 5. So if you see this sort of thing, and it's always good to check for it, see if it might work, it can help you factor a trinomial, a third degree polynomial. Okay? And it's ordinarily pretty challenging to factor a third degree polynomial. You can use long division, but and rational root theorem and stuff that you'll see later. We're not going to cover that in this course. We might do a little long division, I don't know. Okay, so I don't remember seeing it when I looked ahead. Have we done it? Have we done long division? I'm sorry, I'm teaching 3 sequential classes. I've done long division in 1 or 2 of them, but I don't think I've done it here. Okay. Anyhow, there we have it. I think I chose to omit that in this course because that comes in the next one. All right. Let's look at another example. X cubed plus 4x squared plus 3x plus 12. I could factor the x squared out of here. I get an x plus 4. Well, actually, I can factor a 3 out of that one, so that's not really good. Well, there's 2 ways I can look at this, okay? It works if I factor an x out of this and an x out of this. So let's just do that. X times x squared plus 4x squared. X squared times x plus 4. Here, the greatest common factor in these 2 terms is the x squared. Here, the greatest common factor is just your 3. And this gives us a minute there, it looked like it was going to give us the same thing we had up here, but it's got to be different because this polynomial is different. Okay, so that works. But there's another way I could improve this. And sometimes it'll work one way and it won't work the other. I group the x squared and the 3x. So I get the x cubed and the 3x. I could write this as x cubed plus 3x, and then plus 4x squared plus 12. Now I can factor out the x here, and I get x, so let me just do this in blue, x times x plus 3. And then over here, what can I factor out? I can factor out the 4. Now, careless here. If I factor out x, I'm going to get x squared here, right? So x times x squared plus 3 gives x cubed plus 3x. Factor out the 4, and I'm left with x squared plus 3. Well, go back like this equals x plus 4 times x squared plus 3. And you notice that this and this are exactly the same, except for the order of the multiplication here, which is not relevant. Or, order of the multiplication doesn't make any difference. So I've got the same two factors, but two different ways I could do it. Now, you might stop and think, probably don't want to do it, but you could stop and think about, well, if it works one way, does it have to work the other? Here it works both ways. If it doesn't matter which way you do it, you might as well always just take the first two, factor out what you can, take the next two, factor out what you can. Okay? But sometimes you might have to do this. So you might have to group this with this and this with this. And then when you get bigger polynomials, it gets even more fun, but we're not going to worry about anything bigger than this. Okay? So make sure you see that, although, again, this is kind of more important for this course and for the calculus course. But this could be helpful, okay? And I'm going to test you on it. This method probably be only worth half as much as this one. In other words, I might have two problems, we do this, and just one problem, we have to do that. So I'll give you the idea of the relative importance if you've got to make decisions about what to concentrate on. Best if you learn both.